is a continuation of yesterday's lesson, all right? And it is going to be more about radicals, square roots and cube roots and all that good stuff is what we've been dealing with. So as you got your notes out, you'll notice that this is section 8.4. I'm sort of skipping over a couple of, I guess you'd call them intermediate lessons in 8.2 and 8.3 and getting down to the nitty gritty here with this lesson for today. So we're gonna focus on doing some operations with radicals. We're gonna add, subtract, multiply, and divide radicals. Give me just one moment, please. My kettle is boiling over. Sorry about that. My kettle was boiling over. I'm making some hot chocolate. But anyway, as I was saying, we're going to add, subtract, multiply, divide radicals today, okay? And so there's a couple of basic notes. First thing that we're going to mention about adding and subtracting radicals, I want you to write this down, is that to add and subtract radicals, okay, you have to have two things, okay? There's two requirements. You got to have the same radicand and the same root, okay? So the same root and the same radicand. Okay. Now the same root means that I've got to add a square root with a square root or a cube root with a cube root. Okay. Same radicand means I've got to have the square root of 3 plus the square root of 3. I can't say the square root of 3 plus the square root of 5. Those don't work. Okay. So there's two requirements. Once that's in place, then the second thing you would do is you just say, oh, well, okay, I'll add or subtract, whichever it be. Add or subtract the coefficients. All right, the coefficients. Okay, so with that being said, look at example 1 part A with me here, fellas. And what we've got is we've got 2 square root of 2 minus 7 square root of 2. Okay, so I asked, oh, go ahead, Tiago, what you got?
I cannot see your screen.
What is this? Hold on just a moment. Almost. And I'm going to reshare. And how's that looking now?
I still can't see it.
Still can't see it. Rats. Okay. Are you on a mobile device?
Yes, sir.
You and I had this conversation a couple days ago, didn't we?
Yes.
All right. What did you do to fix it a couple days ago?
Well, I had joined after you shared your screen, so then you reshared it. And then it worked.
That worked. Okay. Well, let's try this one more time. We'll stop sharing. Okay. You see me waving at you?
Yes.
Okay. Now we're going to try to share one more time. Desktop. They get you squared away?
No, sir.
Rats. All right. Here, why don't you leave the call and come back in? We'll try that way.
Okay.
And the rest of you guys, I appreciate y'all's patience. We'll get Tiago squared away here. While he's doing that, I'll be right back. I'm assuming the rest of you guys can see what I have been sharing, right? All right, Tiago. All right. Tiago, is it showing up now for you?
Yes, sir.
Good. Good deal, Lucille. We were ready to go. All right, so really, fellas, it's just as easy as saying what's 2x minus 7x, an example like this, right? We'd say negative 5x. Well, that's what we're going to have here. We're going to have negative 5 and square root of 2. All we do is add and subtract the coefficients. We do not change the radicals. Neither the roots nor the radicands. It's literally, like I said, 2x minus 7x is negative 5x. 2 radical 2 minus 7 radical 2 is negative 5 radical 2. That's how we add and subtract square roots, cube roots, what have you. Okay. So with that being said, Paul, why don't you take a stab at part B here? We got 5 cube root of 3 plus 4 cube root of 3. What's that going to wind up giving you? Paul, you want to unmute?
9 cube root of 3.
That a boy. Yeah, easy as pie, right? We just look at the coefficients. We say, all right, well, it was a cube root and a cube root. The radicand was y in each of those cases. So we just say 5 plus 4 is 9. So we got 9 cube root of y. Doesn't get much easier than that. All right, Luke, how about example C? What do you think on 7 fourth root of x minus 2 fourth root of y? What do you think?
5 fourth root of x and y.
All right. Actually, a little trick question here, Luke. Go back and check your first parameter. What do I have to make sure I have in place?
In the same radicand.
Yeah. And so, like I said, a little bit of a trick question. So sorry for throwing you under the bus there, my man. But because these don't have the same radicands, even though they're both fourth roots, I can't put them together. There's no simplifying to do. So I would just say, all right, well, this is about as simple as it gets. That's like saying, like, hey, what's x plus y? You know, x plus y is just x plus y, and there's no combining the two. So good example there for us to remember. First, I must have same root, same radicand. All right. Now, look with me, if you will, at a second example. Okay. And here's where it gets a little bit interesting. You might be thinking, or I don't know if you've been thinking this or not, but you might have thought, well, gee, those first examples were kind of easy, Coach. It seems like this might be a little boring here. Okay. And so, like, I'll throw it, John Zweig, you're on example A right here. What are you thinking as far as our, can we put these two radicals together? John, what do you think, buddy?
Yes.
All right. So you're correct, sort of. We can put these two radicals together, but we got to do something first. Okay, Jake, what do you think we might have to do first to put these two guys together? Because obviously, it's kind of like that last example with Luke. They don't have the same radicands. So what can I do first?
Maybe multiply the 5 by 4.
Okay. We can't just multiply by 4 whenever we want to. That kind of changes the problem. Let me harken back to some of the work that you guys did. And Jake, I know you did a good job of this because I was checking on Delta Math with some of those assignments. You guys remember what we said? What can I do with something like here on this example, square root of 45? What did we say? Split it up where one of the factors is a perfect square. Okay, is everybody remembering that? So now as I look at 20, how can I, Lewis Thomas, how can I split up 20?
4 and 5. And
Yeah,
4
pretty good.
4 is
So
a
square
perfect.
root of 4, square root of 5, and even you guys that are my alpha dog status unlocked guys right at this point, you know, you could probably go ahead and say, oh, that's 2 radical 5 right off the bat. And then throwing it back to John, now, John, what do I get now that I can put these together?
Five radical
Speak up a little bit louder, John.
5 radical 5.
Yes, sir, that's right. 5 radical 5. By the way, I'm glad John said it that way because that's how I've been saying it, but I haven't really spelled this out for us at all. To me, it's easier to say the word radical than to say the words square root of. Okay, so like I would read this as, you know, 5 radical 5 as opposed to saying 5 times the square root of 5. Okay, so you'll hear me. That's just a little jargon that we use there. So keep that in mind, you know, radical 20. Because what's the most frequently used radical that we come across? Which one shows up more often than any others?
Square root of.
Yeah, square roots. Square roots show up, you know, 9 times out of 10 in exercises. So because we're so frequently dealing with square roots, you'll hear a lot of people just say, well, oh, that's, radical 20 plus 3 radical 5. And that's a shorthand way of saying the square root. Okay. Obviously, in part B here, we don't have square roots. We got cubed roots, but we still want to practice simplifying a little bit. Okay. Charlie, what could you pull apart? How could you split up 24 to get it to simplify down here for cube root?
6 and 4.
All right. If it were the square root, I would totally agree. Square root, splitting it up as 6 and 4 would work because 4 is a perfect square. Okay. However, we got a cube root here. So I don't want to split it up with a perfect square factor. I want to split it up with a perfect cube factor, right? 8 being a perfect cube, I could say, well, that's, cube root of 8, cube root of 3. So that's 2 cube root of 3. Okay, a little bit of a bigger one, a little bit of a tougher one. Tiago, if you can still hear me, how would you split up 375? You're muted, Tiago.
I don't know.
All right, let me ask you guys this. Anybody remember your list of perfect cubes? Something jump off the page at you guys for your list of perfect cubes? There in green. Which number do we think would go into 375?
125.
125 indeed. So like we could, just like we did with 24, we could split this up as 125 times 3, and then, whoops, cube root of 125 is 5, and cube root of 3 just stays cube root of 3, right? Now, we've got it to where they're both cube roots. They both have the same radicand, so now I can just subtract their coefficients. So my final answer would be -3 cube root of 3. Okay. Now, that being said, part C, we're gonna up the ante just a little bit more. Yeah, they're both fourth roots, and yeah, we want to simplify both of them, but now they've got coefficients and fractional coefficients nonetheless, right? So what I would recommend doing, man, is just put those coefficients on the back burner, deal with them here in a little bit, and just focus your efforts on simplifying out the fourth root of 48 and the fourth root of 343. Okay, I'm gonna give you guys about a minute. I want y'all to try this one on your own. See if you can simplify out the fourth root of 48, much like we did in class yesterday, much like several of you guys did on the homework. I noticed, like I mentioned, Oxley had, I think Lewis Thomas had finished his. Several of you guys had done a good job on that homework assignment. You have practiced then doing problems just like this. So I'll give you a minute. You guys think about it, and we'll see what shakes out after that. All right, I have successfully procured a couple of jumbo marshmallows for my hot chocolate. Now I'm ready to roll, boys. What do y'all got? Somebody, first guy that puts his hand in the air, on virtual hand or real hand, if I see you, on 4 through to 48. What do we got? Go ahead, Lewis.
16 and 3, and then 16. The fourth root of 16 is 2.
Excellent. Excellent, excellent, excellent. My cat just stepped on my keyboard, by the way. Sorry about that. So we got 1/2 is the coefficient that we're putting on the back burner. All right. And we said 16 times 3. Okay. So 4th root of 16 and 4th root of 3. 4th root of 16 is 2. So we got 2. And then we got 4th root of 3. 2 times the 1/2, those guys are going to cancel each other out. So this first term all boils down to 4th root of 3. Okay, you guys see how that works? So let's see here. Drew Benton, how about you on 243? Did you find any perfect fourths that go into that?
I didn't get to that part.
Okay. Some of you guys, especially if you're taking good notes, y'all might remember 243 we came across in yesterday's, maybe actually the day before yesterday, in our lesson. Let's see here. We had the 5th root of 243, didn't we? And you see where we had the 3 and the 81. Okay. So if I spot that up, if I think, all right, well, I got 2/3 was my coefficient that we put on the back burner, and 243, we said we could split that up as 81 and 3. Okay. So Drew, what's the 4th root of 81?
Three.
Good. So, and again, that's because 3 to the 4th power equals 81. So we got that. And then again, we don't do anything to 4th root of 3 here at the end. These 3's are going to cancel out. So we've got a 2 and a 4th root of 3. Okay. Paul, can I subtract these two radical terms now?
Yes,
Why is that?
because the root and the radicand are the same.
Well said. Well said indeed. And so I'm going to take their coefficients now. If you don't see a number out in front, it's implied to be 1. So James, what would my resulting coefficient be? What do you think, James? James Jacobs, can you hear me? Doing a little thinking, I bet. Hey, check this out. What if it was 1x minus 2x? What would that yield?
-X.
Negative x, right? So if we've got 1 radical minus 2 radical, then that's going to be -1 radical. Or we could just say negative square root, 4th root of 3. Right. So really, it's just a matter, fellas, of can I simplify a radical? Because at first glance, these 3, they probably did not look like, oh man, I can't put those together. Coach Morgan said they're supposed to have the same root and same radicand. But you have to simplify once, sometimes one or both of the radicals in order to be able to put them together. Okay. Not always the easiest of things to do, but if you micromanage, look at what we did on that last one. If you just take it one step at a time, okay, like a carpenter who builds stairs, right? One step at a time. Then you can get that problem right, even though there's lots of moving parts, okay? Any questions about adding and subtracting before we get into multiplying and dividing? All right. So let's talk about multiplying and dividing. Multiplying and dividing is going to be a little bit easier. Okay, multiplying and dividing is going to be a little bit easier than the addition and subtraction. Whereas with the addition and subtraction, we said you had to have the same root, same radicand. With multiplying and dividing, all we have to have is the same radicand. Same root. Pardon. Paul, would you mute yourself? Same root.
Sorry.
That's all good, bro. So we just want to have the same root. So in other words, I can multiply a square root and a square root, a cube root and a cube root. It doesn't matter what their radicands are. As long as I have the same root, we're good to go. Okay. Now, the way that I like to, you guys know that I'm a little bit goofy, and as far as mnemonic devices go, sometimes I'm silly with that way, but it helps me remember, and hopefully it helps you remember. Okay, so here's what we're going to do. To multiply radicals, you're going to multiply what's on the outside by what's on the outside, and what's on the inside by what's on the inside. Okay. Much like with fractions, you know, we do the top with the top and the bottom with the bottom. Here you do the coefficients are going to multiply together, the radicands are going to multiply together, and then you simplify the results. So here's what I would consider typing up for you guys as far as steps go. Multiply the coefficients, multiply the radicands, and then simplify the resulting radical. Simplify the resulting radical. Those are your 3 steps. Wham, bam, thank you, ma'am. Easy enough. Okay. So for this example, for part A, I'll do this one with you guys. We're going to multiply 6 times 3. Okay, so that's 18. We're going to multiply 2 times 10. That's 20. And then we're going to simplify square root of 20, which we just talked about a moment ago, is a square root of 4 and square root of 5. Coefficient goes on the back burner. 18 times 2. So that's 36 square root of 5. Just as simple as pie. Okay. Multiply what's on the outside by what's on the outside. Multiply the inside by what's on the inside. Assuming we've got the same root, we're gravy. That root stays as is. And then we got our answer to simplify. Y'all give me just 1 second. My cat is acting up again. All right. Hey, let's look at another example. Okay. So this time, let's see here. Mossy, can you hear me? I can't remember if your mic was working or not. I know you had a comment that you texted the other day. You got your mic working? I'll take that as a no. All right. So Luke, let me throw it your way. Luke, go ahead and multiply our coefficients. What do we get?
20.
All right. And go ahead, since that was easy enough, multiply your radicands. What do we get?
24.
All right, 24. Notice that I'm leaving this as a cube root. We don't change the root at all. Okay. And then, Tiago, can you pull out a perfect cube from 24? It's a perfect cube factor that goes into 24.
4 times 6.
All right. If it was a square root, I'd love that. Okay. If it was a square root, I'd say good on you. Square root of 4 can simplify down. But here, the cube root of 4 ain't gonna do me much good. Check out what we looked at this one earlier, Tiago, up here at the top. Right? We said that if it was the square root, we'd be gravy. How do we split it up though? Well, since it's a cube root.
I can't see that.
It ain't showing up, or I had it too far away.
It was too small.
Too small. Gotcha. How about that?
Yes, sir.
That a boy. 8 and 3 will get her done. So if I split this up as cube root of 8, cube root of 3, cube root of 8 is 2. 2 times 20 is 40. 40 cube root of 3. And that's where we start getting a little bit more efficient. I don't know if you guys noticed that or not, but like I skipped a couple of intermediate steps there, okay? If I can push you a little bit, I'm going to try and push you to where you can do that simplification step in your head, okay, guys? To where I can say, oh, cube root of 24 has an 8. Cube root of 8 is 2. 2 times 20 is 40. Bada bing, bada boom, okay? So questions up to this point about multiplying radicals? All right, then I'm gonna have y'all try this one. This one we're gonna introduce an extra little wrinkle, okay? And I'm just gonna sit back and see if you can handle that wrinkle. We got the radicands, the roots are the same, so I know I can multiply these two. and then we're going to see about what you guys come up with. This is not an easy question for me to just throw at you, so good luck. I'll give you a little hint. You guys have been chewing on this one for about a minute. And I'll give you a hint here. Consider domain restrictions for our variable here. In other words, what is P allowed to be? What is P not allowed to be? And therefore, what do I need and what do I not need to include in my answer? Okay, so just a little FYI there. Consider domain restrictions. What is P allowed to be? What is P not allowed to be from the initial setup of the problem? Let's take about 30 more seconds. All right, Drew, help me with coefficients, please.
40.
All right. And John, help me with the radicands, please.
$18 p to the 4th.
18 p to the 4th. Fabulous. All right. Now we're going to simplify. Okay. Jake, tell me a perfect square factor of 18 that I could pull out.
9 and 2.
All right. So square root of 9 is 3. So 3 times 40 is 120. That's that step that I'm pushing you guys to do in your head. So there we had a 2 and we got a p to the 4th left over. All right, and then James, I'll throw it your way for p to the 4th. How do I simplify that down? What multiplied by itself, in other words, what squared would give you p to the 4th?
P squared.
Very good. Okay, so we got 120 p squared and then square root of 2 left over. Now here's the question. Do we need absolute value at all? Yes, no, maybe? Those are the options. Give me with a thumbs up if you think we need absolute value. Give me a thumbs down if you think we do not need absolute value. Okay. All right, we're correct for a couple of reasons. Reason number one, at the end of the problem, I've got p squared. Okay, which means that by definition, that radical that we simplified out, the square root of p to the 4th was non-negative. And then perhaps a secondary way of looking at it is that I've got p inside the radicand to begin with. Okay, therefore p is implied here with a domain restriction such that it is greater than or equal to 0. Okay. One of the things about radicals that you and I have not discussed just yet, and I would like you to write it down, is that you're not allowed, here in Algebra 1, you're not allowed to take the square root of a negative number, okay? You're not allowed to take the square root of a negative number. The domain of that function is greater than or equal to 0, which means I can't ever have an input that's negative. So if they've got in a problem square root of 3p, that means that p by definition is greater than or equal to 0, because otherwise we'd be taking the square root of a negative number. And if p is greater than or equal to 0, I certainly don't need any absolute values at the end of the problem. Okay? All right. Go ahead, Tiago, you got a question, then Lewis, I'll follow that up with your question. Tiago, speak up, buddy. I can't hear you.
How did you go from the 2p to the fourth to the 120p to the second?
Gotcha. Okay.
Yeah, that's what I was gonna ask too.
Oh, good. I'll kill 2 birds with 1 stone then here. 18 is the same thing as square root of 9 times square root of 2. All right? And square root of 9 was 3. All right. And so we just consolidated the 40 and the 3 to give us that 120.
Oh, I was wondering how you did like the next step. How you got.
Gotcha.
Yeah.
Me
Okay.
too.
So if we split it up in this case, we got the 120, that's cake. We got square root of 2 at the end. So here we got square root of p to the 4th, right? Now, much like the square root of 9, being 9 being a perfect square, I could just simplify that up to straight up 3, because 3 times 3 equaled 9. I can do the same thing with square root of p to the 4th, because p squared times p squared equals p to the 4th. And also, we got that shortcut here. I'll come out to the side. Remember yesterday we talked about the phrase that pays with power over root, and how we said, oh, that's like p to the 4 over 2, or p to the 2. Okay, so in other words, we could simplify it out that way as we like.
Okay.
That kind of clear it up. Makes sense. Okay. All right, and then our last example. Let's see here. Actually, you know what? Let's call it a day. We'll pause right here, and we'll pick up with more of this tomorrow. And we'll look some more at multiplying, dividing, and then I'll give you guys a homework assignment over the weekend on Delta Math. Okay. I appreciate very much y'all's attendance today. Good work, fellas, and look forward to seeing you again tomorrow. Live Jesus in our hearts.
Forever.
All right. Thanks again, guys.